timer overflow rate, and baud rate generation. This is the baud rate generation logic. The transmit clock and the receive clock determine the speed of the transmission. These clocks are taken from these multiplexers. The multiplexer has 4 inputs. The typical setting for SM0 and SM1 is 0 and 1. Therefore, this input is selected. The T clock selects either one of the clock path. It is the same for the R clock. When the T clock and R clock are both set to 0, timer 1 is selected as the clock source. S mode selects whether the clock source is divided by 2. If the T clock and R clock are both set to 1, then timer 2 is selected as the clock source. Let's use these typical setting. The clock source is from timer 1. The timer 1 overflow rate will determine the speed of the clock. What is timer 1 overflow rate? This is timer 1 configured in 8-bit mode. In 8-bit mode, only TL1 is running. TH1 can be set to any value from 00 to FF. Let's set it to FA. Observe the running of the timer. Observe carefully as the timer reaches FF. When the timer reaches FF, it goes into overflow. When this happens, the content in TH1 will be loaded into TL1. The timer continues to run from FA. Overflow occurs again. The number of overflow in 1 second is called the overflow rate. So what is the current overflow rate? Let's assume that the system clock is 11.0592 MHz. The clock entering the timer would be the system clock divided by 12, which would be 0.9216 MHz. The clock period is 1.085 microseconds. The timer increment by 1 every 1.085 microseconds. It took a total of 6.51 microseconds to reach overflow. The timer overflows every 6.51 microseconds. In 1 second, the timer would have overflow 153,600 times. 153,600 is the overflow rate. The number of overflow in 1 second. Therefore, the transmit and receive clock is 4,800. The baud rate is 4,800 bits per second.